Hello, and welcome to the overview of Project 3 by David, Jing, and Xihan. I'm going to give you a quick overview of what we've been researching this semester. Most of it is based around tree queries, and we've also done a little work with embedded SQL into other programs. We've written this lovely Google Doc that will soon be a Word document in your email. Basically, we were curious about the question you raised, what if we wanted to see who managed who, or who supervised who? And digging into this, we discovered that the tree structure is probably the best way to handle this query. And to really show it, it's always easiest to just pull up some SQL. I'm using the employee table that we used in class. The only change I've made is to add the supervisor varchar 20 null place, and I've already done that, so I'm not going to enter it, but if you just run that command, it'll do exactly what we have. Now I'm going to show you some of what we've accomplished as if you just did that, so the results you see will be what would happen if you were to put that into your database. First off, the first bulletin is how to see just who is supervised by no one. And to do that, again, just where supervisor is null, surprise, it's everyone. That's what you see when there's no data loaded. When you want to see who, the reverse of that, who has subordinates, well, no one, because that's what you see, again, when no data is in. Now, using one of the first main keys to see all the subordinates of a node, you use the connect by line. And again, that shows you that Pamela Tribino is connected to herself. Surprise, surprise. When you want to see parent node, again, you're going to use the join on supervisor command. There's a couple other nodes there's a couple other commands that are in here given over. I'm going to skip a few just because they're all, you can run these on your own time if you're especially curious. But 6, query a brother node. This is actually pretty cool. See who's on the same level as you. It's cool that SQL has this kind of implementation. Creating a temp for 0.7. 0.7 being, again, seeing who all is on the same level. Then there's a few more commands. I think one of the most interesting is finding the root of the current node, or sorry, no, not the root. The checking to see whether the current node is a leaf. That one's a pretty interesting command. Again, uses the collect by command, which is one of the more powerful ones we found in tree structures in SQL. And again, with this data set, everyone's a tree structure. But you can see all the different commands we've put into our paper. There's a couple different ones that just show, everything you'd want to know about a tree-like relationship. And tree structures are great for these kind of supervisor-supervisee relationship. And as it turns out, SQL is pretty well built to handle them. For the last few, again, the paper goes into more details on these, but if you want to embed SQL in other programming languages, it's pretty easy. This is an example of what you would have to put at the beginning of a Java program if you wanted the SQL to be passed these variables. This shows if you wanted to put in C some Excel commands. This says, hey, this is the next part's for SQL. Atomic's an important keyword that makes sure that if any of the SQL statements fail, all of them do, and it doesn't just keep going as if one didn't fail. The cast command is also especially important because it allows you to change data types from SQL to SQL, or SQL to non-SQL, or non-SQL to SQL. It is a great function overall that I think, as we're transferring data between systems and getting it into whatever system we're using to analyze, we'll use a whole lot. And yeah, that's general overview. You'll find the details in the paper, but I think between researching how to do the trees and the embedded SQL, a great add-on to what we've already learned about SQL this semester.